Hello, good morning, good afternoon, good evening, depending on whichever part of the world you're joining from. My name is Mudit, and I'm from Pathway, and I welcome you to this webinar with this very formal hello, but a very warm greeting because we are actually very happy to have you all here. We stream across platforms. This is a collaborative event by Pathway, by Athena AI, and with support from the Developers Club at IIT Delhi. So I welcome you to the session, depending on which part of the world you're joining from, which community you're joining from. If you're new to the ecosystem of Pathway Athena or DevClub IIT Delhi, we'll be happy to give you a quick introduction of this. And this session is one where we have like a small segment by Adrian, where he'll cover some of the aspects. Then we have Shiv, who'll talk about rest of the aspects. All of this will be encapsulating the domain of productionizing LLMs, maintaining them, and all those things, testing them. So that's what we'll be covering today. This is an interactive session. If you have got any doubts or any queries, any bashing that you'd like to do, then you are more than welcome to do that. You can do that via comments, and the audience, your peers, can also see that you're here. So we'll be able to see that, yes, this is what you have to share around the topic that we're discussing on. So without any further ado, let me quickly bring Adrian and Shiv to the stage so they can introduce themselves and their companies. Hi, Shiv and Adrian. Thanks for being with us today. Welcome to this particular session.
Hello, hello.
Hi, Mudit. Thank you for having us.
No, thanks to Athena for you know um, for taking the initiative along with Pathway, and quite hopeful about this session. So why don't we start off with a quick introduction of Pathway and Athena? So Shiv, if you can give a very quick rundown of what Athena is all about and what it does.
Sure. So I'm one of the co-founders of Athena. Thank you for having me again. And we describe ourselves as a collaborative IDE for AI teams. So that means we help product and engineering teams experiment, evaluate, and monitor their AI products.
Okay, that's interesting. We would definitely want to learn more about this. Like, how do you go about it? Because this is something which also circles around the topic, which is relevant, obviously, for the audience as well. Adrian, could you please give a quick introduction of what Pathway is all about?
So thanks again, Widit, for having us. My name is Adrian. I'm one of the co-founders of Pathway. Pathway is all about bringing a developer experience to working with live enterprise data and doing insights out of it. Most recently, the focus has been on putting into place LLM-powered solutions, RAG, with live enterprise data in an enterprise-ready way. So in some sense, we have a complementarity here, Shiv, in terms of building solutions and then making sure they work in practice and monitoring.
Oh, thanks for those descriptions. This is slightly like a lot of the folks in the audience might not have completely gotten a grasp of what the end-to-end spectrum we're covering, but um, I think we'll get into the details. For those of you who do not know Adrian and Shiv, their descriptions are there in the session, but I'll give a very quick introduction of our speakers as well. I think that's there in the presentation, so I think we can jump right into it. Um, my peers from the Dev Club seems to be struggling because I probably have we've like I think there's some issue with the link, but I'm happy to introduce Dev Club and IT Delhi quickly. Um, in the interest of audience's time. So Dev Club is like the apex student body at IT Delhi, which is responsible for bringing and developing the programming and AI culture within the ecosystem at IT Delhi. For those of you who do not know, IT Delhi, as I uh, you know refer to them among my colleagues at Pathway, is the Stanford of India. It's like they have, I think, a good number of unicorn founders from there. It's one of the good engineering institutions. And Himanshu, who's the co-founder of Shiv at Athena AI, is also an IIT Delhi graduate, if I'm correct. So that's a brief introduction about them. So we thought it will be great to have them as an academic community partner, and we're quite thankful to them for the support. I see a reaction from Aditya, who has previously led the club. So good to have you as well, Aditya, here. He's commenting on, I think, their channel. So yeah, welcome everybody. Let's get into the session. So Adrian, over to you. Maybe you can take us into the session. You can walk us through the first segment. To a note to the audience, we are all three on this call itself. It will be primarily led by Adrian and Chef. I'm there to create the questions. You can put them in the comments and we'll pick them towards the end. So over to you, Adrian. Yeah.
Sounds perfect. I'll just figure out how to screen share, and just give me 1 second here.
Awesome. It's visible. Yeah. Over to you.
Wonderful.
By the
So
way, a quick request, if you can also cover the previous slide once quickly for the audience to get a grasp of. Yes, exactly. Yeah. Over to you. Yeah.
yes,
Thanks.
yes. So indeed, here the focus would be to take a look at where we are with topics such as generative AI in the context of users who we could categorize as large scale enterprise users, or at least companies that process large volumes of data and have multiple data sources and multiple usages for their data. And at the same time, there are a couple of customer user logos coming from Pathway and Athina here that the respective companies have been working with. So it's a mix of technology companies that would be closer to bringing to the market solutions for artificial intelligence, such as Intel, which here has multiple kind of facets, not only as a chip producer, but also as a company which delivers frameworks for developing artificial intelligence solutions and the full developer experience. There are users such as government, enterprise, large companies, and their users who are among the most fastest growing cloud players, the SaaS companies out there who are putting into place Gen AI deployments. So the whole spectrum of large scale users. The shared sentiment is really that Gen AI is not just a consumer thing. Of course, consumer applications are super important, but Gen AI is beginning to transform the landscape at organizations. And it's perfectly fair to say that a lot of companies, especially the more traditional companies, were caught by surprise by the speed of adoption, the speed at which Gen AI is changing the experience for how people work, how people think, how people search for information. And there's a kind of in some cases even a clash between traditional enterprise culture, which is often on the slow-moving side, and the ability to bring in a new technology which comes in with its own risks, with its pitfalls, which are completely new to organizations. So the biggest question, the one which is starting to be posed in mid 2024, is really a strategic one. Everybody understands that AI is changing the way we work on a daily basis, and the question is really, how can my organization evolve with AI? What are the use cases where AI can bring quick results? How to let users experiment safely while not violating IT guidelines, while staying on the correct side of of enterprise security, and also not getting, let's say, misled by possible issues with AI. And finally, at a very practical level, what should my organization's AI stack look like? This is a super interesting topic because suddenly organizations which were often kind of more in the data engineering realm, you could say they were more consumers of their own data, have suddenly been teleported into the world of Gen AI, which has a strong machine learning DNA after all, because we're talking about machine learning solutions using LLMs. large language models. So for a lot of organizations, it's like a tectonic shift from very traditional data engineering into completely new challenges in technology stacks and data governance, basing their organization to some extent on the outcomes of machine learning. So this is a bit the scene. One of the main topics at organizations is really to get AI which is specific to the organization. Specific meaning it has access to organizational resources, it has access to private knowledge of a company, it is able to answer questions in a way which would be specific to a given organization's culture, habits, and so on. So starting at the level of actually accessing information which is private to an organization is already a certain challenge. In particular, if you think of the popular chat-based services that you have online from OpenAI and from Microsoft, from Google, they will not necessarily have access to your private data, and even less so to your organization's private data. So you kind of in a slightly different setting. If you want to start to share your data, you have to add certain components to start building systems which have access to this private data, which are custom made. So we're not talking about the fully ready-made, off-the-shelf solutions, but solutions which need a certain level of integration customization. One of the keywords which has sprung up in addition to large language models is that of RAG, or RAG, stands for Retrieval-Augmented Generation. So if you actually Google for Retrieval-Augmented Generation, you may still find a research paper which introduced a very specific technique called RAG, but since then the keyword has come to be understood more broadly as a tool to leverage private data in conjunction with LLM. So you have the ability to retrieve your personal data as needed by the large language model, your private organizational data as needed by the large language model, and make sure that the generation that's being done by Gen AI to produce its answers it includes elements of your organization's data. So we have the concept of an LLM, a large language model, an AI brick that most of you have certainly heard of in the last 2 years. And there's a second concept, which is one of a retriever of something that feeds data into an LLM. So the objective here is to go from general knowledge that LLMs are pretty good at serving by now to organization-specific knowledge with a big heavy plus sign by combining the two components, the LLM, the large language model, and some form of retrieval-augmented generation. And then you get into a system which is not so immediate to deploy, because you suddenly start having all sorts of obstacles in terms of deployment and maintenance in production at scale, because for multiple reasons, you will have different levels of sandboxing of production, staging environments, development environments with access to different data. So it's how to prototype systems which actually have access to production data, all sorts of challenges related to data ingestion, data by the AI component, the data governance and security issues that come in related to PII and access control and so on. And then there's a question of not just making the setup, but making sure it's useful. So you tend to get issues with inaccurate answers, quality issues, which are related to all sorts of components which can fail, data retrieval that was erroneous, outdated, inconsistencies in outputs, hallucinations of the LLM, which, for example, misses information which it was looking for, but defaults based on general knowledge to some kind of generic answer, which doesn't make much sense in the context of your company. And this is a major pain, which is actually blocking the adoption of Gen AI in enterprise quite often. One issue which I'd like to come to and kind of theme the scene around is really that of introducing this type of system into enterprise as an end-to-end system. So you're building a system which has the ability to generate answers, to retrieve data. The components of it are tightly coupled, so you have to look at it as an end-to-end system. Which, from a developer perspective, if you have an end-to-end system, you'll be doing things like end-to-end testing and so on. So all of this framework must come in. At the same time, one major issue is make sure that all of the components that are in use work smoothly together. So if you were to follow a guide based on integrating multiple components, it's pretty clear that the components were not necessarily made to work in the context of your specific use case. They'll not be tuned to your use case, even if they are tuned to work together, which is not always the case. Sometimes not all component combinations for the different elements needed to put into place such a stack have been tested and made to work together. So a bit more on this later. What we do at Pathway is really to resolve issues with these types of deployments by proposing a way to deliver an integrated architecture for putting together LLMs, RAG in one combined system, which is able to extract data live from data sources, make sure the system is always up to date with multiple data sources, and to be able to process data from users in such a way as to provide the right answers by serving this type of AI functionality. If you look at this type of system that we facilitate, so we cannot build it for you in such a way that works for all use cases, but we can facilitate it to the degree of providing templates which work well out of the box and which can still be improved. And if you look at these solutions, they are focused around two major axes. The first one is around acquiring knowledge, making sure the system is able to ingest the data and make sure that the AI component in it is able to use it. So this is the pipeline. We call it the pipeline for processing incoming knowledge and knowledge updates, for pre-processing the indexing of knowledge as needed by the use case. And then the other part is really about using knowledge. And this is about query answering. So it's a kind of chat-like functionality where you can chat with the data. But later on, I'll show you a couple of interfaces which actually don't use a chat. There are other types of user interfaces that you can build. One of the things to say is, if you want to stay at the forefront of generative AI, there's a tight integration between the LLM and the retriever functionality. So the LLM component, which is responsible for reasoning, for data processing, for answering your questions, corresponds with closely with the more engineering-oriented component, the retriever component, which retrieves facts from databases, which acts as a kind of memory for your system, which is more. You could think of the LLM as being the more fancy AI component, and the retriever as being the more data engineering brick in the setup. The retriever is very often a vector search solution. Last year I'd have said vector database, but more often than not, it's some kind of vector search solution, which is part of another solution. But there's more than vector search. There's all kinds of full text search indexes, graph indexes, etc. the two work together. You can think of the two working together in different setups. It can be more on the agentic side that the LLM calls into a retriever. It can be more that there's a kind of external control loop that controls both how the LLM and the retriever behave. However, the two need to be designed together and optimized together, and sometimes the actual interaction between them is really interactive. We in our tests, our CTO put forward a look at how to make a system in which the LLM uses a retriever adaptively as needed, and it allows to reduce the token generation cost, the number of tokens used, by a factor of even 4, while maintaining the same accuracy of answers. So there are strong arguments towards keeping the two parts coupled and optimizing them together. If you look at the way organizations currently approach a problem, it's one in which you put together multiple components, and at first glance, these architecture diagrams are overwhelming. If it's the first time you're looking at this type of a diagram, I recommend using the color coding, which is actually pretty well done in this diagram. It's one that's due to OPIA, which is a non-profit standardization effort going on. We'll get it to them for this diagram. So there's a violet path here, which is around data updates and data indexing, which starts with enterprise data sources and flows through the pipeline of ingesting data, processing it, typically embedding it if we want to use vector retrieval and pushing it into a vector database, a vector index, or some other type of index. And then there's a green pipeline, which is related to inference, to answering questions, which is all about being able to process user queries, retrieve the data that's pertinent to the user query from the vector data index or other type of index used, and then provide responses after appropriate guardrails, after appropriate improvement steps. The thing to say is that each of the red bricks that you see here can include a machine learning component to it. It can be customized, and all of these bricks have to be thought of together, arranged together to make sure that that the optimal results are received. What Pathway is really about simplifying the picture by allowing you to design the same kind of solution and the same kind of architecture, but making sure that there's one actual component which takes care of multiple parts of a process. Actually, if you look at it, it's almost all of the process is pushed into a single Docker container, a single you can say a single process, which is responsible for basically everything around the LLM that takes care of everything from ingesting enterprise data up to serving user queries. All of it in a way where you have one piece of code in which you define all of the bricks together, and in which they all run together kind of seamlessly in lockstep. So this is what we do. We're here to simplify the picture and to allow you to then optimize different parts of it easily as parts of a single software pipeline, not an infrastructure pipeline with multiple bricks. A couple of business use cases where people are excited about adopting Gen AI already. I'll show you a couple which are not around chatbots actually. If you look at an enterprise, there are different departments in it. For those of you who are familiar with enterprise structure, you'll have the traditional division into departments and divisions like sales, marketing, legal. Each of these divisions has their own worries. Of course, software developers, R&D departments also have their own worries, but there are some worries that are specific to certain departments. For example, slides are super important for sales and marketing departments, and being able to quickly work out presentations based on previous presentations is a major part of a sales job. In fact, this struggle to be able to find information efficiently impacts a large part of the workforce, so almost half of digital workers. And in particular, the task of finding material which is organized into slides is a very specific use case, but it is one that appears in almost every sales organization which has even like a dozen of salespeople, each of whom create a couple of sales decks every month for each client meeting. You can quickly estimate how this scales into thousands of sales decks a year, similarly for different types of decks, and you end up with large slides libraries that accumulate over time, that are not really very well organized. It's a kind of data format which is super hard to version, super hard to do anything like, there's no Git for slides, nothing like that. And at the same time, the built-in search functionalities are extremely limited. So the way you would approach the topic by using Pathway is you can easily build up your own solution which solves the problem. We provide a template which is designed in our developer framework, Pathway, for resolving this type of use case. I'll show you how it's done, and I'll also show you basically what to do if you're not interested in slides exactly, but some other similar type of data, where to customize, what needs to be edited and modified. So for the slides AI use case, the topic is really about searching your own searching slide decks. It connects to data sources, which may be various, but in this case, there's a connected Drive folder, connected SharePoint folder. You can connect all types of data that are supported by Pathway. It can include also all sorts of things, from document storage to message brokers such as Kafka, S3 storage, anything you like, web APIs, Scape APIs. You can build your custom connectors to connect to data. And the important point is that once you've connected to the data, it's synchronized live. So somebody updates slides, all of the components, all of the parts of the solutions update. And then you can type in a query like, is it Gen AI for me, let's say, and then you get answers to the question based on the documents that were inserted. So in some case, the answers can be super pertinent. I mean, it's really about finding the slides in the decks, pinpointing the information which can be relevant to a given search, and then you can reuse it in any way you like. So this is like a slide search tool. The user interface that you're seeing here is super light, super simple. It allows you to look at, do some filtering by category and so on. And the interesting point here is, as you will see, is that you can actually do some pre-processing of the documents that are being ingested at indexing time to be able to get more pertinent results. So each of the components that are used in the solution is customizable. It's you can run it. You'll find all the repos are public. You can run it as a couple of Dockerized services. There's a Docker Compose which puts them all together. For those of you who are familiar with running Dockerized services, it should be a matter of minutes to get it started. The architecture is such that you have connected data sources which perform slides parsing and analysis, and here in this case we use vision language model to actually extract metadata from the slides. We get out all the slides descriptions, we parse text for metadata in a customizable way. We do slide indexing, and then we can use this to answer queries in the most pertinent way possible. And if you want to launch this project, there's a YAML configuration file which you can use kind of safely to set up the data sources that you have. You can connect a local file folder, you can connect SharePoint, you can connect Google Drive, you can connect all other files that file sources that you have access to, and web files from the web, etc. You can set the configuration of the different components in the YAML, and in particular, you can also set the different types of tags and categories and information that you may be looking for and that you would need the LLM to extract from the files which are being processed during document processing. And then that's about it. All you need to know if you just want to get it running. But if you want to customize, you can go into the actual pipeline itself and easily modify the code. So look at the source code. The solution is built on top of the Pathway developer framework. It allows you to use components of a base framework which serves for processing live data, and as well as extensions which are specific to large language model applications. You build a parser, you build a document store. In this way, then you build an app which actually launches as a server, which exposes a REST API on the indicated port, and basically you have everything. It kind of looks like a Python program, but when you launch it, you actually have a service which runs 24/7. Pathway is a framework which does not require an external orchestrator, so your process will be running over time. There's a powerful Rust engine underneath, which is actually responsible for processing all the data and pushing it through all of the steps of the pipeline. All of it happens inside one process, one solution. So this is a bit about how we could search in slides to locate information which is pertinent to you, minimizing the risk of missing relevant information at the same time while providing contextually relevant results. This is an example of where an LLM is used at the phase of information indexing, organizing information, and the actual retrieval part on demand is actually rather simple, and it doesn't even require an LLM. It requires a well-tuned, well-optimized index, which is built up by the LLM, but at the type of search, the LLM is not used directly. Another type of UI I'd like to show you, and this is something that I wanted to leave you with as inspiration, and also maybe to pass the floor on to Athina. I wanted to mention spreadsheets as a topic which is absolutely amazing. Spreadsheets have been around since forever, and they're one of the most universally kind of ubiquitous UI for rapid prototyping of solutions which deal with data. So why not use it in RAG? What I wanted to show you is a user interface to a RAG application which connects to an endpoint exposed by Pathway, where you can actually organize your AI answers in a form of the spreadsheet, and whenever files change, the spreadsheet will update the answers to your questions. So you have a magic kind of formula like Pathway AI answer question, which is connected to a RAG endpoint, which is passed down the arguments, which include the question and the document identifier, or the set of document identifiers to which the question is addressed, and you get an AI-generated answer here, which is pertinent. Then you can summarize answers from multiple cells and so on. And there's an indexing pipeline, which you will also find in the repo I was showing a moment ago, which allows you to build up your own solution like this, which does have a question answering endpoint, and which you can connect directly to your Excel or Sheets user interface. This is actually fun because when you have an interface like this, you can quickly sit beside your user, design the actual format of the data that suits them, and then, for example, if you notice that users are asking repeated questions where the questions kind of are always on the same topic, you can actually improve the pipeline, the data ingestion pipeline, to really extract information on this topic, the specific tags that would be pertinent to a given use case. So you can use this as a kind of rapid prototyping tool. I guess this would be it for me. Maybe a word of conclusion about up second. Yep, we invite you cordially to test your to build your own applications and use different types of templates here that would be to test the different, like enable different use cases, try it out in different settings. So all of this is readily deployable as containers, configurable, hackable, and ecosystem friendly. So you'll easily find LangChain and Lambda index integrations. Just go to pathway.com/developers, and you'll get all the app templates you need to get started.
Okay. Well, thanks a lot, Adrian. For this first segment, we covered the aspects around productionizing LLMs and understanding the importance of having a tighter integration among the components. There is another very important aspect, which is something that Shiv will be covering. So I'll quickly loop him in so he can walk us through it. Hey, Shiv, over to you. So you can take us through the testing and evaluation side of things.
Cool. Thank you so much. And thanks, Adrian. That was great. I learned quite a bit. So I'll just share my screen and get into what I'm going to be talking about. Mudit, can you just let me know when my screen is visible?
Yeah, sure. Yes, it's visible now.
Cool, thank you. So what I'll be talking about is, the AI development stack for rapid iteration. So we work with a lot of great teams, and over the last year, we've learned a lot about how these teams are actually shipping things to production a lot faster than most people we see. So I want to talk about. I'll get into this in a second, but I want to talk about how teams set up their development environment, what kind of best practices they use, so that they can actually ship AI products faster and make sure they're still reliable and don't have regressions. So quick background about myself and Athena. So I'm the co-founder of Athena. We are a Y Combinator-backed startup. We describe ourselves as a collaborative IDE that helps teams experiment, evaluate, and monitor production-grade AI products. So we work with a lot of great teams, as I mentioned, like Perplexity, Career Village, Misho, Vetted, Demagi. All of these companies have very large number of users using their AI in production, and so we see the best practices that they use to ship things fast. Now, there's a lot of problems with developing and testing Gen AI because it's a non-deterministic technology, and there's fundamentally a very, very large set of inputs and outputs that you have to test for, which makes this software development lifecycle very difficult. So what we help with is all the way from experimenting with prompts, models, retrievers, building your chains, helping you evaluate all of those things, and then actually also monitoring them in production and having continuous testing there. So I've just added some QR codes here in case anyone wants to connect with me. This is my LinkedIn, and feel free to do that. You can do that now. I'll also have the slide at the end. And then I've also got our website over here, so that if anyone wants to check out what we do, you can find us here as well. Cool. So I'll start with what are the typical goals of an AI team and what are they trying to achieve, right? So typically they're trying to build a product that is accurate, fast, and safe and reliable. Safe and reliable is going to be, and accurate is going to be something that depends very much on what you are looking for. So that could be, it can sometimes be subjective in terms of tone and quality. Usually there's a factual accuracy component. There's a safety component. You don't want the AI to go and say things that it should not, and typically you want very low latency. This is mostly what people care about. And on the developer experience side, you tend to care about a few different things, which is you want to be able to experiment rapidly. You want to be able to ship safely without having regressions. You want to be able to measure changes systematically and track experiments. You want to have visibility into what's actually going on in production, and you want to be able to collaborate with your team. So this is the side that I'll be focusing on for the most part, but of course they're very much interconnected. And you'll find that a typical Gen AI development stack will have some of these components, most of these components. So typically, you will have some kind of prompt management system. Sometimes people will have their prompts directly in their code, and you can use Git as a versioning system. There are some benefits to having to not doing that and to having a separate dedicated prompt management system, which I'll get into. Sometimes you'll often use a framework like LangChain or Llama Index or other frameworks that you'll find these can be great for abstraction, retrieval, chaining, and just a lot of things are taken care of for you. Um, Model routing is essentially it's also sometimes called an AI gateway, and what this lets you do is essentially connect to switch between different LLM models and providers. There can also be other advantages to doing this, like cost and it's essentially a middleware, so you can also have guardrails and other things there, which again, I'll dive into this a little bit more. Typically, it's very common for people to be trying to use LLMs to extract structured output or enforce structured responses in some format. And so this is a component I want to talk about because it comes up so often that, and really there aren't a ton of, I don't think the knowledge around these solutions is very omnipresent. So I want to just touch upon this. And then evaluation and experimentation is what actually helps you move a lot faster. So being able to measure your responses, if you can measure them, you can actually test, try different things out and quickly move forward much faster. And then observability is going to be what's actually happening in production. That can help you with debugging, with analytics, with knowing what's going on with real user queries. So I'll start with just the fundamental problem that people face and why they tend to use a prompt management tool. Basically, when you're working with prompts, you're dealing with a non-deterministic technology, testing one and a very large set of inputs that people could be passing in. So testing one input at a time is really not going to give you much meaningful signal. Also, different prompts are going to work well for different models, and they're not always going to be the same prompt might not work equally well with different models. So when OpenAI switches from GPT-4o to GPT-4o mini, the same prompt might not do as well. Or if you want to switch from GPT-4o to Claude, you might want to change your prompt. And manual review tends to be very tedious because often the output that you're dealing with is also large text. So if you have to review that large text at every iteration and there's no easy or convenient way for you to do that, it can be, you can have an extremely slow iteration cycle. And this is really, I think, where most people go wrong is, one of these things is you're just not testing with large enough input sets and you don't have a good system for manual review. Manual review is very important, don't get me wrong, but you do need to have that alongside automated evaluation, and you also need to have a really easy way. You need to make it easy for you and your team to do manual review. Um, and yeah, and so prompt management systems sort of solve many parts of this. They let you separate the prompts from the code release process, like similar to what a CMS does. They let you allow non-technical users to write and edit prompts. It doesn't always have to be engineers who are writing the prompts. It allows you to test with different models easily and version control. And so generally it's a good practice not to have hard-coded prompts, because it'll allow you to separate your code release process from your actual prompt. So even if you find something's not working well in production, you can always roll back to a previous prompt version. If you want to have non-technical users use it, things like that. Testing on a large set of inputs, again, this is one where a lot of people get it wrong. So it's really important to, when you're writing prompts and you're testing different models, or you're testing any kind of change, you ideally want to be testing it on a large batch every time. And this is where Adrian's point about the spreadsheet makes a ton of sense. And this is something which we've leaned very heavily into. So our platform looks very much like a spreadsheet. It's modeled after that. You'll find that a lot of the things are exactly what you would expect from a spreadsheet. And so the things that you can set up here are, for example, I've got one column with the Claude Sonnet response, one with the Llama 3 response, and one with the GPT-4o response. And this just allows me to do some pretty rapid human review and some rapid testing. And then I can also evaluate them automatically and see how it's performing. So again, having some kind of setup that lets you essentially do this and have different models or different prompts that you can test side by side, having automated evaluation, having some manual review system, those kind of things go a very long way towards being able to iterate rapidly. Version control is pretty important, like I already went over. And then, yeah, so when you're iterating, again, batch testing, evaluation, and eyeballing, and having an easy way to do eyeballing. One note about evaluation is that it's very important to make sure the evaluations, if you're using automatic evaluations, very important to make sure these are actually calibrated to measure what you care about. And that's pretty difficult. Evaluations are not, typically what you're testing for. It can often be subjective. For example, the quality of a chatbot response, let's say, is not there are aspects of that you can measure, like conciseness, coherence, whether the answer is relevant, whether it is faithful, things like that. But there's often a quality aspect which makes it which is hard to measure with automatic evaluations, and that's where eyeballing or human review can come into the picture. Cool. So moving on to model routing. Model routing is essentially the idea that you'll have a gateway or a middleware that will allow you to connect that'll allow you to switch between different model providers. And this is something we've seen from most teams. They don't really want to be locked into a single model or a single provider anymore. People want the option to say, hey, Anthropic's just come out with some great models. I want to switch from OpenAI to Anthropic. Doesn't mean you want to change all your prompts. Doesn't mean you want to change everything in your code to make it work for that. So typically you want to have some kind of layer in the middle, which is going to do some normalization. You can build that yourself, or you can use something like Light LLM or Portkey. I've used these. They're great tools, and I would recommend them. And essentially what they do is they normalize the format for all of these models into one. They can also have some other benefits, like, for example, helping you optimize your costs, having some caching layer in there that can improve your latency and cost. One other thing that comes up a lot when you're working with any kind of LLM in production is structured outputs. So LLMs are inherently non-deterministic, but you want your application to work 100% of the time. And structured outputs are a pretty good way to do that. So instead of asking the LLM to return blob of text, which is very hard to actually manipulate with code, you can ask them to return a JSON object, which is very easy to manipulate with code. But it's not trivial to do that. They don't always listen to you when you ask them to return JSON. There's a lot of use cases for this, like intent classification, determining which tool to use, data extraction. I mean, there's so many reasons why people do this. But like I said, it's not always trivial. So I've listed down a few methods here that I've seen people use. And there's also this great article by Boundary, which is a fellow YC company. They have this article which essentially lists every way to get structured output from LLMs. One of them is BAML, which is their own framework, and but they've listed all these other methods as well. This is pretty good resource, so you can find this here as well on their website. And OpenAI I think just 2 days ago, they launched structured outputs in their API. So what you can now do is you can provide a JSON schema and ask the LLM to return that JSON schema, and it will do that. And it will do that with a very high degree of accuracy. They previously had JSON mode as well, which was similar but not as controllable. So you couldn't provide the schema. Yeah, this is actually a really great way to do it. But this is only OpenAI. The other models don't have it. So there are dedicated libraries, like Marvin is a great one that I've used as well. BAML, which I showed you, Instructor. There are a few of these. One thing to note about these dedicated libraries is that they will typically make an additional LLM call. So essentially your first LLM call will also get piped into another LLM call, which will then return the response. So it can make not always, but mostly, so it can make the latency and cost worse. But again, if you do need structured output, then these are good resources for you. And then moving on to evaluation, evaluation is probably the one part of this entire stack that I think you just cannot get away without. Like evaluation is just something which, if you don't have it, you are just not going to be able to move fast at all, and you'll have no idea if your model is getting worse or better. So in development, it's useful for measuring responses, moving faster. In CI/CD, it can help you prevent regressions, and then in production, it can help you understand how your AI is performing in the wild. And there's different ways to do evaluation. There's human review, there's user feedback, and then there's automated evaluation. Mostly, I'm talking about automated evaluation. Human review, again, spreadsheets are a great way to do this. User feedback is, imagine a thumbs up, thumbs down that people will click in your application. The problem with that is that the data tends to be very sparse and it's not representative, because users will only click the thumbs up or thumbs down button for outlier cases. And so you don't really get great signal from that. You can get some, but not really, not too much. There's also implicit feedback based on user actions. So that's going to be something like, imagine that you're generating an email using AI. If the user edits, and let's say you're generating a 100-word email, if the user edits 20 of those words, then that means you got 80 out of 100 of the words correct. So that can give you some signal, and those are pretty great ways to measure, truly how close is your AI response to what you need it to be. But there's also automated evaluation. The most flexible of these is LLM as a judge. It's not perfect, but what you can get, you can basically ask an LLM to do the evaluation for you, and imagine something like, is this answer relevant to this query, right? Now that's a response where if you prompt it correctly and well enough, then you can get pretty good results from this. And there are libraries, and we have our own SDK that helps you do this as well. So these are just some examples. We've got over 50 evaluation metrics, many of which use as LLM as a judge. We also integrate with libraries like Ragas. And this can be, so this is sort of, think of it like a shortcut to evaluation, but it's really, evaluations are not a one size fits all. They are going to very much depend on your data and your task. And so it's really important that you can also configure your own evaluation metrics. So whatever your evaluation setup, make sure that it's flexible and modular enough that you can actually swap between different evaluation metrics if you find that the off-the-shelf solutions are not good enough for you. There's a lot of libraries out there, but just make sure you can swap between them. Again, it should be very easy to run evaluations on large batches. You should ideally be able to also run the same evaluations during development and production, because if you have a different benchmark in production than you do in development, it can make it hard to sort of draw any meaningful conclusions. That being said, in development, you might have ground truth data, and in production, you're not going to have ground truth data, and you're going to have very high volume. So it's not always possible, but if you can have some setup like that, then that would be great. And then obviously ways to track experiments and have human annotation. So I'll just give you a quick demo of what that looks like. This is what our platform looks like. As I showed you, this is a very simple data set that I have in here. So what you can do is we have this idea of dynamic columns. The idea here is that I can just select, I can generate a column that can be an API call, a classification task, custom code, or an LLM a retrieval or an LLM prompt. So for example, I could say um, answer this query, or what I could do is I could just import from a prompt that I've already written. And so I can so now I'm saying answer this query, and I can choose version 2 of my prompt. And then if I run this, what you'll find is that a new column will be generated with all of those responses. And it just gets generated live. So again, we've taken the idea of spreadsheets that Adrian mentioned to a different level. We really believe that this is a great way for people to test and try out responses. Now, let's say I want to try the same thing, but with Llama 3 instead. I can always just go and do that. And I can switch it up, I can change it. And if I just run this, it'll update that entire column. Or, and then what I can also do is I can run evaluations. So for example, let's say I'm just going to add a saved evaluation that I already have, which just checks if this response is a good answer for this query. So if I run this one, you'll see that again, we just create another column and we'll start to just populate this with passed and failed. And so again, the same idea that you saw in this data set over here, that you can run these, and then once it's done, you will also see the score at the bottom with the average score and the metrics on what was the pass rate, what was the median, and the breakdown by percentile. So that's, this is kind of the setup that we've seen a lot of teams, even when they don't use Athena, they'll have some internal tool that might look something similar to this. So again, just the same ideas of being able to test in bulk, being able to run automatic evaluations easily, being able to swap between different evaluations, add custom evaluations. And then last thing is a very common workflow people have is that they want to test multiple prompts and multiple models at once. So we actually built a special feature for that called Experiment. And so the idea is here that I can add as many prompts as I want. So for example, I have prompt 1, prompt 2, and then for each prompt, I can have as many models as I want. So for example, I can do GPT-4o mini, Llama 3, let's say 7dB, then maybe I'll do this one with GPT-4o mini and Command Lite, and I'll just switch up this prompt so that it's slightly different. So now I've got this prompt with these two models, this prompt with these two models. And again, I can even run the evaluation. So I'll run the same one. And once I run this, you'll see that, so I have to give it a name. And then once I run it, you'll see that we're just going to generate all of those data sets live. So data set A was my original data set. Data set B was GPT-4o mini. So this is prompt 1 with GPT-4o mini. This is prompt 1 with Llama 3 7dB. This is prompt 2 with GPT-4o mini. And this is prompt 2 with Command Lite. And it'll take a couple of seconds to complete. But there we go. So you can see that now we've got all of these responses, and all the evaluations are also populating over here. And so very quickly you'll be able to actually see how well it's doing. You can see the cost and performance, the token usage, response times. If I click into it, I can compare all of these responses side by side. So I mean, you can see that if you're testing this one by one, I just ran this on 30 rows and generated 1, 2, 3, 4. I've got 150 responses over here, and I've run the evaluations, so I can see which one is actually doing best. And if you're doing this manually, you can imagine that this will take 150 times longer than it probably should. So that's the idea, just like have the right tools, build them yourself, or use something like Athena, but have the right tools to help you, to help you actually speed up your development, and you can truly move a lot faster. And the last part of this is just production monitoring, which I won't go too deep into because I know we're over time. But the idea is just having visibility in production and again, having the same metrics in production that we talked about earlier. That can help you also just really quickly understand what's going on and loop that back into what you're doing. So yeah, thank you everyone. Thank you so much. And here's how you can connect with me or find more about Athena if you're interested.
Thanks, thanks a lot, Jeff, for the presentation. There's one quick question that we can try to pick. Um, so one question is that I've received on a DM, and second is from the comments. First one is around the evaluation metrics. So the question is like, is it's from Milind? Is there a particular guide on figuring out which evaluation technique works best for my Gen AI use case? Maybe there's a document on Athena's document itself.
Yeah, we do have some guides in our document, although not as much as I would like. I think it depends. So for each task, so like let's say, if your task is RAG, there's a lot of guides on what are good RAG evaluations. If your task is summarization, again, you'll find a lot of different guides. Same with data extraction. So you will find guides if your task fits into one of these buckets neatly. When you have more complex tasks or you're trying to do something pretty different, you might have to come up with your own. I think the best way to think about it is to work backwards on, if you were reviewing it manually, what are the aspects or the pieces that you would actually try to measure, and then figure out what is the evaluation metric that will actually represent those well, and that will map to that. Hopefully that answers it, though I know it's not as concrete as just pointing to a guide, which I would
Yeah,
like
and
to.
besides, it's a problem statement which can be like continuously relooked at and then refined each time. So um,
Absolutely.
there's one thing that like I received over DM, which is on the LLM as a judge part, and it is slightly at the juncture of what Adrian shared and what Shiv shared, and it is basically there's an adaptive RAG bit that Adrian mentioned that was presented by Jan, who's the CTO of Pathway. And the question is precisely that, is the LLM as a judge bit similar to what the adaptive RAG does or not? That is precisely the question. If you can take it, Adrian, maybe because you have the context around adaptive RAG bit, or maybe Shiv, if you have read that piece, then you can also cover it. Yeah.
Yeah, I think I'll let Adrian take this one.
Okay.
So this is actually a great question, because using LLM as a judge is the general approach. So you let the LLM be a judge of, in this case, whether it has seen enough information, whether it has seen the right information, whether it's able to answer. And at the same time, you try to put some kind of guardrails on it, just to to limit the amount of misinformation the judge can introduce into the process. So in this case, the judge just answers, "I cannot answer," or "I'm able to answer, and I'm convinced I know how to answer."
Okay. Fair enough.
But this is a fascinating topic in general, whether LLMs are actually better at generating answers or evaluating answers, and we could go on for hours on this, I guess, looking at different setups.
Yeah. Correct. Yes. Fair enough. But yeah, given the timeline, I think we are almost out of questions. So I would say this is where I would thank all our attendees. There have been quite a few questions which have been answered by the community. There were questions from Sivaranjani, there were comments from Asin, Milind, Harun, and everyone else. There was Piotr, one of his students, who shared he was a student at one of the universities. So he had quite no ad from Damien, sorry. So there was a mixed representation from the community. But thanks everyone who joined. For those who are in Europe, Asia, or Australia, this is a bit later in the day. Thanks for joining in so late. And for those in the States, thanks for joining in the morning as well, including Chef, who I know starts the day. Like he has to coordinate with teams across the globe, so he actually took out the effort to join in early, so our counterparts from Europe and Asia can join in comfortably. Thanks for that, Shiv, and thanks a lot, Adrian, for taking out the effort and driving the community through this particular session.
Thank you so much for hosting.
Thank you so much, and I'm looking forward to seeing more and more, instances, deployments of Pathway being monitored by Athena, seeing the two in action together. That's something.
Absolutely.
Sounds promising. Thank you.
Sounds awesome. Thanks, everyone. Thank you. Bye bye.
Thank you. Bye bye.
Bye.